Welcome to Key Safety Talks. Today, we're breaking down the absolute must-know critical rules for scaffold safety. This is the stuff that keeps you and your crew safe on site every single day.
And for this safety explainer, we're not just pulling ideas out of thin air. Nope, we are going straight to the source, using the comprehensive Aramco Scaffold Safety Handbook as our guide. Everything we talk about comes directly from this guide.
So here's the plan. We'll start with the bedrock, your safety foundation. Then we'll get into preventing falls, making sure the scaffold is stable, why every single component matters, and then how to build safe platforms and access. And we'll finish up with a rapid-fire recap of the most important points. All right, let's get into it. We're starting with the core principles, the things that are completely non-negotiable when it comes to scaffold safety. First up, maximum intended load. Now listen up, because this is key. This isn't about how much the scaffold weighs. It's about the total weight of everything you plan to put on it. That's all your people, all your tools, and all your materials. You have to know this number before you even start building. And here's the magic number, the safety factor that you have to remember. 4 times. Every single part of that scaffold, from the smallest coupler to the longest tube, has to be able to support its own weight, plus at least 4 times that maximum intended load we just talked about. That's your safety margin. That's what stands between a normal workday and a total collapse. Okay, now let's talk about the biggest danger on any job site with a scaffold. Falls from height. There's a very specific rule that you just can't ignore. And this is that number, 1.8 meters, or about 6 feet. If you're on a platform where you could possibly fall more than that distance, you must be protected by a fall protection system. There are no ifs, ands, or buts about it. So you've basically got 2 options. On one hand, you've got guardrail systems. Think of these as passive protection. They're just there, doing their job, whether you think about them or not. On the other hand, you have personal fall arrest systems. You know, your harness and lanyard. That's active protection, meaning it only works if you use it correctly. And that's exactly why a physical barrier, like a solid guardrail, is always the preferred choice. It's just safer. So what makes a guardrail a proper guardrail? Well, here's your 4-point check. Is the top rail at the right height? Is there a mid-rail smack in the middle? Is there a toe board to stop a wrench from falling on someone's head? And is the whole thing strong enough to take a 200-pound force? If the answer to any of those is no, it's not a compliant guardrail. Simple as that. Now, if you absolutely have to use a personal fall arrest system, your anchor point is everything. It is literally your lifeline. And it can't just be anything. You can't tie off to a guardrail or a piece of conduit. No way. It has to be a fixed point that can support at least 5,000 pounds. To put that in perspective, that's roughly the weight of a small car. You wouldn't trust a weak rope to hold a car, so don't trust a weak anchor point with your life. Okay, so we're protected from falls. But what about the entire scaffold coming down? Let's talk about stability and the simple ratio that keeps it standing upright. This is the golden rule of scaffold stability, the 4-to-1 ratio. It's pretty straightforward. You take the narrowest width of the scaffold's base, multiply it by 4, and that's the absolute maximum height you can go before you need to add extra support. But what happens when the job needs you to go higher? I mean, it happens all the time, right? You can't just cross your fingers and hope for the best. You have to physically restrain it. You can use ties to anchor it to a nearby building, run guy wires down to the ground, or you can widen the base with outriggers. Whatever you do, the goal is the same. You have to stop that thing from tipping over. You know, a scaffold is really just a system of parts, and that system is only as strong as its weakest link. That's why inspecting every single piece is so incredibly important. And this right here shows you why. Just look at the difference in these numbers. A right-angle coupler can handle almost twice the load of a swivel coupler. So imagine you accidentally use a swivel where a heavy-duty right angle is needed. You've just cut your safety margin right in half without even realizing it. That's why using the right component is critical. So the bottom line is this. There is zero, and I mean zero, tolerance for bad equipment. A bent tube, a rusted coupler, a plank with a split in it, it doesn't get a second chance. You mark it, you get it away from the good gear, and you get it off the site, period. Let's talk about plank spans for a second. If you're using standard 38mm planks, that's your typical 1.5-inch wood plank, this is your maximum distance between supports, 5 feet, no more. But if you've got the thicker 50mm or 2-inch planks, you can stretch that span out to 2.4 meters, which is about 8 feet. Knowing what planks you're using is fundamental to building the scaffold correctly. All right, we've got a stable structure. with good components. Now, let's put it all together and talk about the part you actually work on, the platform itself. Building that platform right comes down to 4 key rules. 1, it's got to be fully planked, no dangerous gaps for your foot to fall through. 2, where planks meet, they have to overlap on a support by at least a foot. 3, you need to control the overhang at the end of a run to prevent a tipping hazard. And 4, the platform needs to be at least 3 planks wide to give you a safe working area. And getting on and off the platform? Well, if you have to step up or down more than about 2 feet, you need proper access, like a ladder. The one thing you never, ever, ever do is climb the scaffold frame like it's a jungle gym. That's how accidents happen. Okay, let's bring it all home. We've covered a lot, so let's lock in the absolute most critical takeaways from this entire safety talk. Number 1, fall protection. Anytime you're working 1.8 meters or 6 feet off the ground, you need to be protected. That means a full guardrail system or a personal fall arrest system. It's not optional. Number 2, stability. Remember the 4-to-1 ratio. If the height is more than 4 times the base width, that scaffold must be tied off, guide down, or brace without rears. Number 3, inspect everything. Before you use any piece of equipment, give it a look. If it's bent, cracked, rusted, or damaged in any way, it doesn't get used. It gets tagged and removed from the site. Number 4, your foundation. Scaffolds need a solid base. That means steel base plates under every post. And if you're on soft ground like dirt, you need timber sills under those plates to spread the load. And finally, number 5, your working platform. It has to be fully planked from end to end and fully guarded with a top rail, mid rail, and toe board. This protects you from falling, and it protects the crew working below you from falling objects. So take these rules with you. Make them second nature. Every time you walk on site, look at the scaffolds and ask yourself this question: are we meeting this standard? Because at the end of the day, this isn't about passing an inspection. It's about making sure every single person on your crew gets to go home safe. That's what really matters. Stay safe out there.